Today we have a quadratic and discriminant problem. So we're given y equals x squared plus 2x and y equals kx minus 1. And we're asked to find the values of k, i.e. this k over here, for which the curves do not intersect. So if we start off just by sketching these, and to do that we'll first factorise the quadratic. So y equals x squared plus 2x, we can rewrite as x lots of x plus 2. So if we go to draw that on a axis, what we have is that one root is at the origin, the other one's at minus 2. So it'll be something along these lines. It doesn't have to be a perfect drawing, as long as we get a rough idea of where the points are going to be. And then for the second curve, we know that it's going to go through the y-intercept is going to be minus 1. So we can draw that on as well. But we don't know the gradient. So all we know is that it's definitely going to cross over at this point here, but we don't know the gradient of that line. So we've got kind of an option. We can draw something like this where it's a bit shallow. It could be very steep, something like this along these lines. Could be completely flat. That's perfectly fine as well. Could be going down. We don't know. Our job is to figure out which one of these gradients is going to be kind of allowed with our idea of not intersecting these two curves. So the way we'll do this is by setting them equal to each other and then trying to find one quadratic from that and looking at the discriminant of that thing. So setting these two equal to each other, we've got x squared plus 2x is equal to kx minus 1. We'll bring everything to the left-hand side to form one quadratic by itself. So we'll have x squared plus 2 minus k, lots of x, coming from, we already had two of them. We've taken k away, so it's going to be 2 minus k. And then this minus 1 we'll add over, and we'll have a plus 1 on the left. So now we want to look at the discriminant. If these two curves don't intersect, it's exactly the same as saying that this quadratic has no roots. And to find no roots, we want to look at the discriminant, i.e. b squared minus 4ac. And we want that discriminant to be negative. The reason this works is if you think about the quadratic formula, we end up square rooting the discriminant, but we're not allowed to square root negative numbers. So we end up breaking the formula, and therefore we get no answers to the formula. So that tells us there's no roots of the quadratic at all, no real roots anyway. So the discriminant in this case, we've got b, which is 2 minus k. We want to square that thing. And then we'll take away 4 times a, which is 1, times c, which is also 1. So 4 times 1 times 1 is just 4. So we'll take that away. And that thing is going to all be negative. Now we could expand these brackets and solve this like a quadratic for k. But it's a little bit easier if we just add the 4 over, and we'll get 2 minus k all squared is less than 4. And then square root. But one thing to note is when you square root with the inequality, we're not just going to get this one over here, but we'll also have the other side. So we can think about that as being the modulus. So i.e. the size of this thing is less than 2. Now we're allowed to swap these over. It's a bit weird that we can swap them over. But if we think about doing 7 take away 5, we get 2. And 5 take away 7, we get minus 2. So yeah, one's positive, one's negative, but they have the same size, the same magnitude. And that's really what these things are talking about here, these two kind of straight lines either side of the 2 minus k. So we can swap them around. We'll have k minus 2. Modulus of is less than 2. And now we can split that modulus into two separate inequalities, but we can write it as one inequality, i.e. having a minus 2, which is less than k minus 2, which is less than 2. And now we can add 2 to both sides, or to all three sides even, and end up with 0 is less than k, which is less than 4. And this then will be our final answer. So what we can see is we look back at the graph, there's going to be some line going kind of through our line here, through the point minus 1, and just making a tangent with it. And that'll be the line with the gradient of 4 just touching the curve. The one I already drew of like the horizontal line here is a gradient of 0. So it's showing that it should actually just kind of be a tangent to this curve over here. But any then gradient in between these two, if I change this one to purple, any gradient in between the two should not intersect. So kind of in this range over here is all good. Everything the other side will cross over with this white quadratic we've got on the left-hand side there. It's beautiful. Thank you very much.